Every product has a story, a journey from raw materials to finished innovation. Step inside the world's most advanced factories and discover the machines, technology, and processes that make it all possible. Welcome to Process Intelligence AI, where industry meets intelligence, inside the amazing process of recycling old tires into steel ingots. INTRO, every year, billions of worn-out tires reach the end of their life. Most people see them as waste, but hidden inside every tire is a valuable resource, steel. In this video, you'll discover the fascinating industrial process that transforms discarded tires into solid steel ingots through advanced recycling and metallurgical technology. From extracting steel fibers buried deep inside used tires to melting, casting, cooling, and producing reusable steel blocks. This is the complete journey from waste to valuable metal. Let's step inside the factory. Section 1, Tire Collection and Transport. The recycling process begins with the collection of used and damaged tires from vehicle service centers, scrap yards, and municipal waste facilities. Thousands of tires arrive at recycling plants every day. Before processing, the tires are inspected to remove contaminants such as dirt, stones, and foreign materials that could damage industrial machinery. Large conveyor systems then transport the tires toward the shredding section. Modern recycling facilities are capable of processing several tons of waste tires every hour. Section 2, Primary Shredding. Whole tires are too large to process directly. Heavy-duty industrial shredders equipped with powerful rotating blades tear the tires into smaller pieces. These machines generate enormous cutting forces, allowing them to break down thick rubber and reinforced steel belts. The shredded tire pieces typically range from 50 to 150 millimeters in size. Reducing the tire size not only improves handling efficiency, but also prepares the material for steel separation. Section 3, Steel Extraction. Hidden inside every vehicle tire are high-strength steel wires. These steel reinforcements provide structural strength and durability during a tire's service life. After shredding, advanced magnetic separation systems are used to recover the steel. Powerful magnets positioned above conveyor belts attract and remove steel fragments from the rubber material. Additional granulation and secondary separation stages further improve metal recovery rates. Modern recycling plants can recover more than 95% of the steel contained inside waste tires. The separated steel fibers are collected and prepared for melting. Section 4, Cleaning and Preparation. Before entering the furnace, the recovered steel must be cleaned. Residual rubber, textile fibers, and contaminants are removed using mechanical cleaning equipment. Some facilities also use air classification systems to separate lightweight impurities. The clean steel scrap is then compressed into dense bundles or loaded directly into charging containers. Proper preparation ensures efficient melting and helps produce high-quality recycled steel. Once prepared, the material is transported to the steelmaking section. Section 5, Melting in the Furnace. The steel scrap is charged into high-temperature furnaces. Many recycling facilities utilize electric arc furnaces because of their efficiency and ability to process recycled metals. Inside the furnace, temperatures can exceed 1,600 degrees Celsius. Powerful electric arcs generate intense heat, rapidly melting the steel scrap into molten metal during melting. Slag-forming materials are added to capture impurities. This purification stage improves the chemical composition and overall quality of the recycled steel. Continuous monitoring ensures that the molten steel meets strict industrial standards. Section 6, Casting Steel Ingots. Once the molten steel reaches the desired composition, it is ready for casting. The liquid metal is carefully poured into specially designed molds. These molds determine the size and shape of the final steel ingots. As the molten metal fills the molds, controlled cooling begins. Industrial casting systems ensure uniform solidification, minimizing internal defects and improving product quality. Within a short time, the glowing molten steel gradually transforms into solid blocks. Section 7, Cooling and Finishing. After casting, the newly formed steel ingots enter the cooling stage. Depending on production requirements, cooling may occur naturally or under controlled conditions. Once fully solidified, the ingots are removed from the molds. The surfaces are inspected for cracks, defects, or irregularities. Additional finishing processes such as grinding, cutting, or surface cleaning may be performed to achieve precise specifications. Each ingot is then weighed, marked, and prepared for shipment.
Conclusion.
What began as discarded tires destined for landfills has now become valuable industrial raw material through advanced recycling technology. Steel hidden inside waste tires is recovered, purified, melted, and transformed into new steel ingots ready for manufacturing. This remarkable process not only conserves natural resources, but also reduces environmental waste and supports a more sustainable circular economy. Thanks for watching. If you enjoyed this journey inside modern recycling technology, don't forget to like, subscribe, and turn on notifications for more fascinating industrial process videos. Channel Process Intelligence AI, Manufacturing Explained with AI.